So welcome to this session on Fourier series. Here we will be just learning the basics of Fourier series and some problem solving techniques. Now a series summation un is convergent if limit Sn tending to infinity of un equal to L. This I will just change it to Sn. A series Sn is convergent if limit Sn tending to infinity Sn is L, and divergent if limit Sn tending to infinity Sn is plus or minus infinity. Now a real valued function f is said to be periodic of period t if f of x plus t equal to fx where t greater than 0. We have the Euler's formula which states that fx equal to a0 by 2 plus summation n taking value 1 to infinity an cos nx plus bn sin nx, where a0 is 1 by pi integral c to c plus 2 pi fx dx, an is 1 by pi integral c to c plus 2 pi fx cos nx dx, bn is 1 by pi integral c to c plus 2 pi fx sin nx dx. And we use this result of integration that integral e raised to ax cos bx dx is e raised to ax by a squared plus b squared, a cos bx plus b sin bx, and integral e raised to ax sin bx dx is equal to e raised to ax by a squared plus b squared, a sin bx minus b cos bx. Again, if n is an integer, sin n pi is 0 and cos n pi is minus 1 raised to n. We'll start with a simple problem. Obtain the Fourier series for the function fx equal to x squared in the closed interval minus pi to pi, and hence deduce that 1 by 1 squared minus 1 by 2 squared plus 1 by 3 squared minus 1 by 4 squared and so on is pi squared by 12. So a0 is 1 by pi integral minus pi to pi fx dx, that is 1 by pi integral minus pi to pi x squared dx. This is an even function, so this is 2 by pi integral 0 to pi x squared dx. Integral of x squared is x cubed by 3 within the limit 0 to pi, so this is 2 pi squared by 3. An is 1 by pi integral minus pi to pi fx cos nx dx. Fx is x squared, so it is 1 by pi integral minus pi to pi x squared cos nx dx. It is an even function, so this is 2 by pi integral 0 to pi x squared cos nx dx. So this is 2 by pi. You can apply integration by parts. The order is right. So x squared integral cos nx is sin nx by n within the limit 0 to pi minus integral 0 to pi 2x sin nx dx. That is again 0 minus 2 by n integral 0 to pi x sin nx dx. So that will give you, again integrate by parts, you get minus 4 by n pi x. Integral of sin is minus cos nx by n within the limit 0 to pi minus minus plus integral 0 to pi. I have taken the 2 by n outside, and this is cos nx dx. So you get 4 by n squared into minus 1 raised to n. Again, bn is 1 by pi integral minus pi to pi fx sin nx dx, that is 1 by pi integral minus pi to pi x squared sin nx dx, which is 0 because it's an odd function. So your Fourier series of fx is pi squared by 3 a0. a0 is pi squared, 2 pi squared by 3. So 2 pi squared by 3 by 2 will give you pi squared by 3 plus summation n taking value 1 to infinity 4 by n squared minus 1 raised to n cos nx. And if I put x as 0, you get 0 is pi squared by 3 plus summation n taking value 1 to infinity 4 minus 1 raised to n by n squared. That is, shifting this to the left, you get minus pi squared by 3 is minus 4 plus 4 by 2 squared minus 4 by 3 squared and so on. So you can divide by 4 here, so you get pi squared by 12 and multiply by minus 1 is 1 minus 1 by 2 squared plus 1 by 3 squared minus 1 by 4 squared and so on. So this is my first session on Fourier series. For more, please get in touch with me. Thank you.